Have you ever written a simple Python script and then wondered, how does this become a real professional library? You know, the kind anyone in the world can just pip install? Well, that journey from a single file to a global package is exactly what we're going to break down. So here's the game plan. We're going to start with the absolute basics. We're talking files and folders. Then we'll get into the magic of the _init.py file. From there, we'll see how to package up a project using modern tools, take a quick peek at the history behind those tools, figure out how to share our work with the world on PyPI, and then wrap things up by looking at the whole philosophy behind Python's packaging ecosystem.
All right, let's start at square one. Before we can even think about building huge libraries, we have to get a handle on how Python organizes code at the most basic level.
At its heart, the simplest, most fundamental unit of reusable code in Python is just a single file. Seriously, you write some functions, save it as, say, myutils.py, and boom, you've officially created what Python calls a module. It's the atom of your entire codebase. Okay, so what happens when your project grows and you've got more than one file? Well, you start grouping related modules together in a folder. And that folder, that collection of modules, that's what we call a package. It's the natural next step up from a single script to a more organized project. But what really makes a folder an official package in Python's eyes? That brings us to the secret ingredient. There's this one special little file that basically waves a flag at the Python interpreter and says, hey, this isn't just any old folder. This is a package you can import stuff from. And this is it, the init.py file. You'll hear people call it the dunder init file because of the double underscores. Its mere presence inside a directory is what tells Python, okay, this is a regular package. And the crazy part? It can be completely empty. Just the fact that it exists is enough to change everything. And this is a really important distinction. A folder with that __init.py file is a regular package. That's the one you'll see 99% of the time. But a folder without it, that's what's called a namespace package. It's a more advanced feature that lets a package be split across different places. It's super flexible, but that flexibility comes with a price. Python has to search more, which can make your imports a bit slower. Now, this file isn't just a marker. It's actual runnable code. The very first time you import anything from that package, Python finds the init.py and runs whatever code is inside it. After that, it's done. The package gets cached, and the code won't run again, no matter how many more times you import it. This makes it the perfect spot for any one-time setup you need to do. So what do you put in there? Well, all sorts of useful stuff. You can define a version number for your whole package, like _version equals 1.00. Or, my favorite, you can import specific functions from your other modules to create a really clean, simple API. That way, your users don't have to remember some long, complicated import path. And of course, you can just leave it empty and let it be a marker. Okay, so we've got our code neatly organized into modules and packages. But as projects get bigger, we need more than just folders. We need a way to define metadata, list all the other libraries our project depends on, and give instructions on how to build it. And listen, if you've been doing Python for a while, you've probably felt this pain. You start a project, and before you know it, you've got a setup.py, a setup.cfg, a requirements.txt, maybe a manifest.in. Your project directory just becomes this junk drawer of config files. It gets confusing fast. This quote here really nails that feeling of historical clutter. For a long, long time, this was just how you packaged a Python project. It worked, sure, but it was definitely not what you'd call elegance. Thankfully, the Python community came together and created a single standardized file to bring order to all this chaos, pyproject.toml. This file is now the modern central nervous system for configuring a Python project. And you can see just how powerful it is by looking at its structure. The build system section tells tools like pip what it needs to actually build your project. The project section has all the core info, name, version, what other packages it needs. The project scripts part is awesome. It lets you turn a Python function into a command you can run right from your terminal. And then tool.star is this brilliant catch-all section for configuring all your other dev tools, like formatters and linters, keeping everything in one tidy file. Now, a file this important didn't just appear out of thin air. It's really the result of more than 2 decades of trial and error and evolution in Python's packaging world. This timeline really tells the story. It all started way back in 2000 with distutils. Then setutools came along and was a huge improvement. But the real game changer for users was pip in 2008. It made installing packages so easy. Then the Python Packaging Authority, or PyPI, was formed to sort of guide all these different tools. And all that work eventually led to the 2020 standard that officially crowned pyproject.toml as the new king. All right, so you've done it. Your code is structured, your pyproject.toml file is perfect, your library is ready for the spotlight. How do you actually get it out there for other people to use? It's pretty much a three-step dance. First, you lock in your configuration. Then, you use a tool simply called build. This creates the files people will actually download. A source distribution, which is just your raw code, and something called a wheel. A wheel is a pre-built version that makes installation way faster for users. Finally, you use another tool called Twine to securely upload those files to PyPI, the Python package index.
Okay, for our last section, let's zoom all the way out and talk about the big picture. Why does Python's packaging world feel the way it does with all these separate little tools?
It really boils down to a core philosophy. On the one hand, you get incredible flexibility. You can pick and choose the tools you like best. This allows for a ton of innovation because small, focused tools can change and improve really quickly. It's that classic Unix philosophy of do one thing and do it well. But there's a flip side. For newcomers, it can be totally overwhelming. That's the paradox of choice. There's no single, official, blessed way to do things. This comparison really makes the difference clear. In Python, you get a toolkit of small, specialized tools. Pip for installing, build for building, Twine for uploading. You put them together to create your own workflow. In the Node.js world, you basically get one giant tool, npm, that does everything. Installing, building, publishing, the whole shebang. It's just a fundamentally different approach to the problem. And that leaves us with this final big question to think about. Is this flexibility a feature or a bug? Is it a strength that lets the ecosystem innovate like crazy? Or is it a weakness that just creates confusion and a steeper learning curve for developers? There's really no right answer here, but understanding that trade-off is absolutely key to navigating and mastering the world of Python packaging.